Well, hello and welcome YouTube, Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always it is an honor and a privilege to be serving you here today, as it is every day, here in my virtual classroom. Step on aside as we jump into the section 7.1 to 7.3 quiz, or quiz review of the Big Ideas Math Integrated Math 1 textbook. This is on things regarding statistics, mean, median, mode, standard deviation, range, interquartile range, 5-number summary, box and whisker plots, histograms, analyzing data when it's symmetric, left skew, right skew, etc. I'm sure all those things are involved in these sections. And actually, if you came off my 7.3 video, you might know that I've actually come off a hiatus of recording videos for a long time. 7.3 was my most recent one. 7.1 and 7.2 I did a long time ago. So not that I hope I know what I'm doing, but that I hope I know what I taught or how the book talked about it, or to re-remind myself of, oh yeah, that's kind of what was covered. So just kind of keep that in mind if I bring these things up. We do have 9 problems to cover. They should be a breeze. We'll see how they work. Jump to the descriptions down below if you want to find the timestamps for each individual problem, as well as a PDF for this individual page. Without further ado, guys, I'm going to go ahead and get started here. We are going to find the mean, median, mode of the data set of numbers 1 and 2, and they also ask which measure of center best represents the data and to explain. I'm going to have to remember that second part on what they're asking for it and why. Let me think about it when we actually get into that one. So for number 1 itself, when they're asking for the mean, and this is one of those things that I don't remember, did I actually put like X bar? This X bar is also another way to say mean. So I don't know if I actually put that itself. I'll just leave it up on top just because I don't know. But to find the mean for these values, you will add them up and divide by the number of values that there are. Now, because they're using mixed number values, I'm going to stick with those. These are half values, so common denominator, pretty easy to add. I'm going to be doing 3.5 plus 3 plus 5 plus 3.5 plus 2.5 plus 1/2. The mean means the average. Add these up, divide by how many there are. There are 6 of them. So, I feel like I did X bar equals. I'll do that next time. Or I'll do it right here. Is that okay? Okay. All right. So, 6.5, 11.5. Don't make me mess up here. 15 plus 3 is 18. So, 18 divided by 6. And that'll give you 3. So, the mean value is 3. I'm not going to pretend to know what this is about. If we were to give context, let's say the amount of time spent on something, okay, the average number of hours. So the average number of hours was 3 hours, kind of like that. Okay, the median. I don't know if there's a variable for it, and if there was before, I don't remember. I apologize. The median. Let's take these values and rank them in order first. We got 1/2 as the smallest value, and then 2.5. A 3, couple 3.5s, write them both, and then the 5. Now the median value in a set is the middle value, but in an even numbered set there are 2 middle values such as these ones. That makes the median the average of these 2 values, I guess the mean of them, if you will. We are going to take these 2 numbers, add them up, and divide by 2. That becomes 6.5 divided by 2. Now if you don't know what 6.5 divided by 2 is as an exact thing, here's what you probably would do. Now, first let me give you the answer. It would be 3.25. But if you don't know what it actually is, I mean, you can have 6.5 is 6.5, divided by 2 is 3.25, convert it back. Yeah. But let's say you wanted to work in this part as well. Ideally, could you divide the 6 by 2 and the 1/2 by 2 separately? Yes. In fact, I kind of actually would probably recommend that. Unless there's overlap. Let me think about that. Trying to think in a situation, you know what, maybe I wouldn't always recommend that, because what if it was 7.5 divided by 2? 7 divided by 2 is 3.5, and that kind of works. Anyway, here's what I would do. I'm sorry about belaboring this. Convert this to its mixed number. 6.5 is also 13 halves. Now that's something you're going to have to know how to do. And dividing by 2 means multiplying by 1/2. So times 1/2 there, and you're getting 13/4. Now, how does that convert to 3.25? The fact that these numbers are all the same here is kind of coincidental in different writing. 13/4 is, 3.25. 4 goes into 13 3 times with a 1/4 remaining, and that's what we get. Anyway, a lot to say on how to do that individual division. I apologize. I just wanted to bring that up. Okay, the mode, and I won't spend as long talking about that next time. The mode asks which number appears most among all of them. And that answer is 3.5. 3.5 appears most among all of them. Now, if any one number didn't exist more than any other, then there would be no mode. If there were multiple numbers that existed more than twice, I should say, then each of them would be parts of the mode, if that makes sense. Which best represents the data? I want to say median. That's not always the case. I just want to say median, just that 3 is in the data set. So is 3.5. But this number is kind of in between those values that makes me feel like it is. I don't know. I used to answer those questions before, but I want to type that out and kind of say it that way because the other numbers exist in the data set and they're not in the center itself. I feel like the one more in the middle kind of works out. So the median best represents the data because it's in the middle of the data, center of the data. I don't know. I kind of like that. Even more so than the mean value is in there and the mode value is in there. It's actually literally the average of the mean and the mode together. That's kind of weird. So I think that works best for me. I don't know. I answered those ones before. That's one of the ones where I'm like, yeah, kind of iffy. But I like my version of my answer there. I like justifying that one. Sometimes they can seem opinionated. Sometimes they'll be more obvious than not. All right, number 2, they're asking for the same 3 things. So for the mean, we're going to do the same thing, x bar. We are going to add these up and then divide by how many there are. There are 9 of them. So we'll be doing this. I don't remember how often we had to do this. Hold on, I'm going to run out of room. I don't know how often we had to do this in the previous section at the time. But if it was a lot and there were big data sets, I can imagine sometimes I just skipped the actual writing of this step and just said, here guys, we'll just do this in the calculator. You do it yourself. But there are only 2 problems that we're doing this for as far as I'm concerned, so I'll do them. All right, we're dividing this whole thing by 9. Now I will use the calculator to actually punch these things in. Let me do it right here. So I got 1,000 plus, where's plus? 1, 2. Now I want to show the calculator portion for a reason here. Don't divide by 9 right now like this because I'm only dividing 1,100 by 9. You want to divide everything by 9. So you either have to put parentheses around everything or find this sum first. And I don't think the sum has actual meaning for you. Besides, it's just the sum of the values. But that will be the mean. We're going to round. The last one use a fraction. This is a repeat. That 0.8 repeating means 8/9. We could use a fraction version of it if you prefer it. I'll kind of write both. I could say it's about, whoops, not that part, about. It's about, what was my number? 1314.8 repeating. So 1314.9, or it's exactly 1314 and 8/9. Now that's just me knowing that. That's stuff you might have to like put together yourself. Okay, the median, same thing as before. We are putting them in order and finding the middle value. There are 9 values this time, so it will be the 5th number of 9 is the middle number. And I know that sounds weird. You're like, isn't 5 of 10 the middle? Well, 10's an even numbered set. So think from 1 and 9, 2 and 8, 3 and 7, 4 and 6, 5. 5 is in the middle of a list from 1 to 9. So let's go in order here. The smallest numbers, these are all in the 4 digits, but the smallest 2 values are each 1,000. Let me cross them off this list as I go so I can see what I have and don't have. Let's look in the 1100s now. Literally, there's an 1100. And then an 1180 and 1191. 1180, 1191. Then 1200, 1267, 1328. And then there's a 2000s value, which is 2568. Okay, Boom, 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 boom. Now, technically, I only needed to know up to the 5th number here. I already was aware that the 5th number was all I needed, so I could have probably stopped right there. Unless we're going to use this information for anything else. Maybe. I don't know. So there's that. And, now that we're looking more at this one when we're talking about which thing is the best representation of the center, does the mean look like a better representation of the center of your data than the median? The mean is 1300 whatever. It's really close to this value that's on the tail end of that. It doesn't really seem like it is. And the reason for this is because this number is really pushing the mean upward. So the median is a better representation, once again, of this stuff here. The mean generally is whenever you have more symmetric data, and this doesn't seem to be that. Neither was the previous one, apparently, at least not enough. Now the mode, so here's the median, by the way. The median is 1191. The mode is, once again, the value that occurs most frequently, and I believe that's 1000, and once again, that seems to be not really in the center of the data. So the median is the best representation of the center of your data, once again. I'm not going to say why this is. I'll say why the others aren't. Because the mean and mode are on far ends of the data. Now, that doesn't mean that these... See, the median is kind of the reason why it wouldn't be... Oh, let's see. How do I say this best? You want to argue reasons not why the median is, but why the other ones aren't. Because the median's always in the middle of your data. Literally, that's what median means, the middle of them when they're ranked in order. But that doesn't always mean that it's the best center of representation, right? If there were a bunch of 1000s here, if there were like 5 1000s, even though the median still is what it was, I might err toward the mode at that point. Of course, the mean might be a better representation pulling that way, but, if there are a lot that are 1000s, literally with that, I might actually point to mode in that case. Anyway, find the range and standard deviation of each data set, then compare your results. We have numbers 3 and 4 here. Now, they said each data set individually. So, absent students during a week of school. Well, on Monday, there were 6. Tuesday, there were 2. I think like that. That's what they mean. So, let's look at females only here. So, for female, the range is the difference from your largest number and your smallest number. Now, these are not written in order, right? And if we need standard deviation, we're going to have to use some other, do we need median? I guess not really. So the smallest number is 2, the largest number is 6. 6 minus 2 is 4. The range from the lowest to the highest is that. Not from Monday to Friday, but from Monday and Tuesday, as you can see there. Male, let's just do that while we're here, because standard deviation has a lot more to do. So we're on the same line for range right now. I hope that's okay. So smallest number is 3, highest number is 9. So 9 minus 3 gives you 6. Now, standard deviation, there's a large formula associated with it, and it first starts by finding the mean. You actually need to find the mean within it. I'm not going to write the formula itself, but I will explain all the things that you need to do. We find the mean, we find the difference of all your values from the mean and square them, and add those values together. I know it's a lot. Divide by the number of values there are and take the square root. Yikes, that's a lot. We start by finding the mean, though. So, the mean of this thing, the first one, 6 plus 2 plus 4 plus 3 plus 4... 8, 12, 15, 19. Ew. Is that right? Let me check that one more time. 8, 12, 15, 19. And that is, it's a perfect decimal. I just need to write it somewhere else. 19 over 5. That's 3.8. Is that right? That's not the answer, by the way. This is just mean. We're going to do some other stuff with it. So X bar for this guy, for male, let's break these up a little, is 5 plus 3 plus 6 plus 6 plus 9 all over 5. So 8, 14, 20, 29 over 5, which is 5.8. 0.8. So neither of these are pretty, which is unfortunate because we have to take the sum of the squares of your values. And this is one of the things, I'm not going to say I forget how to do. I forget how to arrange it best. Like if we found a good streamlined way to do it, if the book found a good streamlined way to do it, whatever. I don't actually remember. So I kind of want to show you the formula itself, how everything's used in like one shot. Standard deviation, I believe, is the sigma symbol right there. Now what you're going to do here, let me do females first, okay? Female. Okay, so for female first, standard deviation. I'm having so much trouble since coming back from my hiatus, guys. I'm sorry if this is like bad. We're going to take the difference between all these numbers and 3.8, and we're going to square those numbers individually. So 6 minus 3.8 squared plus 2 minus 3.8 squared. And this is probably the part, I probably didn't organize it this way, right? We might have written them as a list or something like that. I don't actually know. 4 minus 3.8 squared, 3 minus 3.8 squared, and 4 minus 3.8 squared. And then we add these up. We divide by how many numbers, once again, there are in that, and we're going to take the square root. So with those 5, we're going to do that. I'm running out of room down here. Let's do... Okay, so that's 2.2 squared plus negative 1.8 squared plus 0.2 squared plus negative 0.8 squared plus 0.2 squared. Now, a lot of this I could and probably should just do this in the calculator, even though I know most of these here. I have to add them up anyway, so I probably will. Let me just do that part from there and get you the rest. I'll try and do it all in one step, order of operations wise. So I'm going to start with the square root. In my numerator, I'm squaring 2.2. And it doesn't matter if the numbers were positive or negative. The 1.8 was negative, but let me just write 1.8 squared. When you square it, it'll turn positive. I think it's in my best interest to just do that now. 0.2 squared, they're actually 2.2 squareds, but negative 0.8 squared of that, 0.2 squared here. Now I'm dividing this all by 5, and 5 is inside that square root like that. So hopefully all this should take care of what I need for standard deviation. And there I'm getting 1.326. I'm going to say 1.33. So standard deviation for the girls there, 1.33. Maybe, how about just 1.3? We rounded to 1 decimal place for the mean was 1 decimal place. And so we have it there. And if you were with me for section 7.3, you actually might know what the standard deviation means with the 68, 95, 99, 7 rule. We add and subtract 1.3 from 3.8, and we can say how much of the data actually falls within that range or is expected to, which is really cool. All right, I'm going to do the same thing for males on the other side, guys. Let me copy paste, and I'll do it kind of faster this time. Having trouble. So X bar. Okay, so my mean was 5.8, and I need these data values here. So this next standard deviation, I'm going to subtract these internally, if that's okay, the numbers that I'm going to square here. 5 minus 5.8 is negative 0.8. 3 minus 5.8 is negative 2.8. 6 minus 5.8 is 0.2, and then another 0.2. And then 9 minus 5.8 is 3.2. We're dividing that one by 5 and taking that square root as well. So we're going to do the same thing as before with the males, the men, and that is, this time I actually, wait, hold on a second, hold on. First parenthesis for the square root, second one's for the numerator, third one is for the number I'm squaring. This time I'll actually put the negative. Make sure you wrap it around parentheses when you do, though. Otherwise, it'll actually treat it as a positive. Oh no, negative 2.8. That would mess up everything. I don't need to do it around the positives. Plus 0.2 squared plus 3.2 squared. Close the parentheses there for the numerator. Divide by 5, and if you'd like to, close the parentheses for the square root. And there we go. We get 1.94, around 1 decimal place, 1.9 for males. Now, I don't think they asked us questions. Oh, they did. They said compare your results. So what I want to compare here is the males on average. What was the female? 3.8? So the males on average were absent more than females during the week. The female standard deviation was 1.3. The males is 1.9. The higher average, I'm not going to say has nothing to do with a larger standard deviation. Not at all. Or it doesn't necessarily. But that there is more spread there. The higher the standard deviation, the more spread there is with your data. So the male absence values are more spread out. That's what our results can say. You can also say that from the range. The male absences data is more spread out. Are more spread out? Whatever. Okay, that was number 3. You know, when I saw 1 through 9, I was like, all right, this is going to be like a 9-minute video. It's going to be a breeze. It's been 21 minutes. So, yeah, it's been three problems. So, 7 minutes of problem. You know what? That's statistics for you. Number of points scored by juniors and seniors. I'm curious as to what sport this would be and how it's spread out. If this is a basketball game, man, these are great point spreads. So I don't know specifically what we're talking about here. So let's start going. So the range and standard deviation. Range ain't much. We know that. Let's find a way to sort this better. Range. All right. Juniors. Seniors. Okay. For juniors, find your highest and lowest numbers here. 10 looks like the lowest, and I think 21's the highest, correct? Let's go with that. 21 minus 10. See, if you put them in order, that would very much help, especially if you have a larger data set. I'm just going based off what I see. Only two-digit numbers and nothing higher than the 20s. Seniors, again, only two-digit numbers. Look in the teens for now. 15 is the smallest. 30s, we go up to the 30s, it looks like. 32 is the highest. So 32 minus 15. And that will be 17. Okay, standard deviation. Again, there's no shortcut. Well, there are some if you use the calculator, stuff like that. But there's no shortcut to actually getting these things done. First, you need... let me copy paste this part, actually. Give me a second. First, you need the mean. It's probably faster for me to just write that out, but... So, average out your values. I'm going to average them kind of like without showing work, if that's okay. There are 1, 2, 3, 4, 5, 6, 7, 8 values each. So let's see. Let me try this in my head. 19 plus 15 is 34. Plus 20 is 54. So 64, 78, 99, 117, 132. I don't know 132 divided by 8. 16.5. So I'm going to write 16.5 for these guys. Again, not the answer. Seniors. 22, 41, 70, 102, big numbers, 117, 143, 173, 192. 192 divided by 8. I know that. What's wrong with me? I have no idea. 24? 192 divided by 8. Hold on. I don't actually know. Oh, I put 1928. 192 divided by 8. 24. Excuse me. Okay, so I'm hoping those are correct because I'm not quite done, so I'm just going to keep going off of that. Okay, I'm going to do the standard deviations by subtracting the numbers and squaring them and doing all that kind of stuff from before. So I actually might have room to fit in here if I write small enough and just do the subtractions. So this first one, they are 0.5s though. So 19 minus 16.5, 15 minus 16.5, and I know it's negative. Is it okay if I just write the positive version? We're going to square it anyway. 20 minus 16.5. Oh, I'm not going to have enough room at all. This is rough. Yo. 10 minus 16.5. 14 minus 16.5. 21 minus 16.5. 18 minus 16.5. And 15 minus 16.5. So bad practices from me for a few things, the main one being not using negatives when I probably should be. If we were dealing with something called correlation coefficient, you'd actually have to make sure that you have the proper sign with it. So again, bad practice on my end. My goal for this as the second problem at this point probably is just getting the right answer and understanding what it is that you're doing as that formula. If you saw what I did on number 3, then hopefully that will be enough for it. Okay, so because I'm just very low on room for that as an overall. My sense of coming back here is recognizing that I don't have the luxury of time all the time anymore, so I kind of make do where I can. Hope that's okay. If you get it, that's the important part, and if you don't, ask down below and see if I can work with you a little more. I only hope I calculated these right, you know what I mean? I did the even the addition in my head, and now this part I'm trusting that I did the 0.5s correctly. Divided by 8 there inside the square root. So I'm getting 3.4-ish on that standard deviation for juniors. So, and I don't know, I'm going to check really fast if we're interpreting standard deviation later at all using these rules. If not, I might bring it up for this problem. Let me look at the questions really fast. Box and whisker plot, just going to describe the shape. Find the mean median mode. The price one's 5% discount. Identify the shape of the distribution. 10 minutes long. I don't think they will talk about the standard deviation stuff later. So I might do it here and just interpret this for you guys because 7.3 did talk about that. Okay, let me do seniors briefly here as well. These actually, I might be able to fit these numbers because they're not going to be decimals. So let's see. Where did we start here? So 22 minus 24, so 2 squared. Is it okay if I just put the numbers on these ones here, guys? Like 22 minus 2 is negative 2. Negative 2 squared is 4, right? Boom, squaring that number. 19 minus 24 is negative 5. Squared is 25. Boom, plus. 29 minus 24 is 5. Squared is 25. Boom, plus. 32 minus 24 is 8. Squared is 64. Boom, plus. 15 minus 24 is 9. Squared is 81. Plus. What number did I say? 15. 26 minus 24 is 2. Squared is 4. Plus. 30 minus 24 is 6. Squared is 36. Plus. 19 minus 24 is 5. Squared is 25. Okay, let's see. 25, 25, 70, 75 there. Plus 40 is 115. Plus... Let's see. Now I need these 3 to go. 85. 115 plus 85 is 200. 264 divided by 8. I'm going to go with that. So 264 over 8. I'm going to see how much I can do in my head before I have to actually give up. 225. 33. 33 square root of 33. Which is going to be around, I don't know, 5.8. Sure. Let's see. Square root of 33. 5.74. So, boom, 5.7. There we go. That's as much I did without the calculator till I hit the square root. Okay, so we have to interpret these things here. Seniors had a larger range. They had a higher standard deviation. Seniors are more spread out, or their points scored. Senior points scored are more spread out than juniors. Now, what is standard deviation? And I'm not going to speak super long on it, but I want to do some calculations with you guys on it. It has to do with first of all, it would have to do with the fact that these numbers are considered to be rather symmetric as data. And I don't know for any fact that either of these sets are. These might contain outliers and such. I'm actually not sure if these are the best measures to use for center, mean and standard deviation, because that's a 7.3 thing that I'm sure we will talk about. But the idea of this is, and I kind of mentioned it in passing before, and I'm going to use 24 as the example right now for seniors. If this data is pretty symmetric toward the mean, meaning most of the values bunch toward the mean and you have symmetry going that way, then you can interpret seniors' data as in being able to predict how much of the data will fall within this mean in this way. Standard deviation means what it sounds like. In a standardized format, how far will you deviate be off of the mean? What's the expected amount? So the higher the number is, the more spread out your data is. If I do 24 plus 5.7, here, let me do this. Let me do a little bell curve. If I do, and I know I'm just sticking on this problem a little bit longer. Here's my mean 24, and here's how my data spreads. If I add 5.7 to 24, I get 29.7. If I subtract 5.7 from 24, I get 18.3. What this tells you, there's a rule. It's called the 68, 95, 99, 7 rule. When you add one standard deviation left and right, add and subtract one standard deviation from the mean, that accounts for 68% of your data. We're saying that 68% of all senior points scored will fall somewhere between 18.3 and 29.7 points. Now, that's kind of weird because you can probably only do integer amounts of points, but at least for precision's sake, you want to say that. Let's argue, for argument's sake, between 18 and 30. About 68% of your data falls between 18 and 30. Add and subtract another 5.7 over here, and then plus 5.7, there's 35.4. Subtract 5.7 here is, 12.6. I don't know if the numbers are perfect, but let's say there. So that says 95% of your data falls between these two numbers of your senior points scored. That's how the spread works. 95% of it falls between there. And 99.7 is the third one. The book doesn't even bring up the 99.7. But if you add another 5, it's basically all 100% of it, save a few outliers here and there. But that's the general expectation of what happens there, and that's where we use standard deviation. Now, if the other one's 3.4, there's less spread overall. There's less variation. Despite the fact that the mean is smaller, that's not necessarily relevant. But if there's a smaller spread, that means that the numbers will fall closer to 16.5, then these numbers will fall toward 24. You can even tell when we squared these numbers that they seemed bigger. I squared 9 over here. Highest I scored here was 6.5, and you get the gist. Okay, that's it for number 4. And I am not holding my end of... I increased my average to probably about 8 minutes a problem now, so hope that's okay. I slowed down I sped up to slow down in talking about those things differently. Okay, numbers 5 and 6. Make a box and whisker plot that represents the data. Now, a box and whisker plot uses what is known as a 5-number summary. So I'm going to get all those data points for you in just a moment here. Let me write the original set. I don't think I've been doing that lately. So let me actually do that this time. Here's the ages of family members. We've got some grandpop-pops. We got a little 15-year-old. Older brother, some cousin. Dad, mom, dad, I don't know. Anyway, so... you really do want to rearrange these in order first, just bar none. So let's start with the 15-year-old, then 20 and 25, 30, 40, 55, 60, 70. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right. All right, here's rearranged in order here. Now, this is important because we're going to find 5 values to make a box and whisker plot for it. We're going to find the min value or the least value, Q1 and Q3. I'll save those after I get the median. Median is basically Q2. It's the second quartile. And the maximum value. Then we'll draw a box and whisker plot off that. Min value is 15. Max is 70. Least and greatest. Median is the middle value, and when there are 2 middle values, you average them. 30 plus 40 divided by 2 is 35. So 35 is your median. Now, we ignore the actual median, which is 35, when considering the medians of these other 2 values here, Q1 and Q3. Q1 is the median of the first half of your data, and Q3 is the median of the second half of your data. So Q1 is halfway between 20 and 25, which is 22.5. Average them. And Q3 is halfway between 55 and 60, which is 57.5. Add them up to divide by 2. So we are going to be using those to make our box and whisker plot off of those specific 5 values. So what we'll do is construct some form of like a number line. Go by increments of, say, 5, if I can fit them all. I'm really not going to have to go any lower than 15. So let's say this is 15, 20, 25, 30, 35, 40, 45. Oh, this is probably too small. 15, 20, 25, 30, 35, 40, 45, 50, 55. Oh, shoot. It was probably good the first time. 30, 35, 40, 45, 50, 55, 60, 65, 70. For some reason, I thought we were ending at 55. I have no idea. I was just looking up here. My bad, guys. 15, 20, 25, 30. And then the second time I caught it. Okay, I'm good just going to my ends right there. Okay, so on this box and whisker plot here, I have my min and my max there. I have my median at 35, despite the fact that no one's actually aged 35 this year. That's where it is. Halfway between 25 and 30, no, between 20 and 25 is our Q1, 22 and a half. Halfway between 55 and 60 is our Q3, like that. And what I'm doing is I'm drawing my box of my inner quartile data from Q1 to Q3, and my whiskers as segments going like that and like that. So make a box and whisker plot. I just did. The units for these are ages, so I'll just go ahead and write ages for family members, and there we have it. Okay, number 6, minutes of violin practice. This time I will not copy down the data, but I will be using it to write out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 bits of data. Let's find the mins and go from there. They're all by increments of 10. It looks like 20 is the smallest, and there's several of them. 1, 2, 3 20s. Oh, there is a 35 there, so I don't want to overrule that. So I got a 30, and then the 35. So 30 and 35. Couple 40s, 1, 2, 3 40s. If we're talking mode here, I have mode of 20 and 40, but we're not. So a couple 40s, couple 50s, couple 60s. 50, 50, 60, 60. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. All right. So same thing as before. 5 number summary. Our minimum value is 20. Our maximum, our maximum value is 60. Our median, it is again an even number set, halfway between 1, 2, 3, 4, 5, 6 and 6, so 40 and 40 is 40. And your first and second halves of this, we have to find those medians, the number halfway between 20 and 30, and then halfway between 50 and 50. So 25 here and 50 there. Okay, that'll be your 5 number summary. I can probably use the same number line here that I had before for way different context, because they just seem to kind of have the same spread, and we can use those intervals. So let's just go ahead and do that. After all, it took me so long last time. So our minimum value is 20. Max is 60. We got our median here. Q3. Q1. And we'll do our box and whisker plot there. Okay. Okay. Okay, unless they ask me to interpret it, I'm just going to go ahead and leave it at that for now. Okay, number 7. Display the data in a histogram. Describe the shape of the distribution. Okay. So, they have all the information for us to just draw it right now. The way I've been doing histograms for you guys is just doing kind of a first quadrant dealio. Doing by good increments here. We have to go up to 16. Ooh, so let's go by twos. I should have told 1, 2, 3, 4, 5, 6, 7, 8. Let's go up by increments of 2. Hope that's okay. To hit 16 at the top there. That means halfway in between these will be the odd numbers, right? And there's 0. Now you need to spread these things out here. 0 to 2 is 3 values, 0, 1, and 2, and then 3, 4, 5. Those are equal increments of 3 each time. 1, 2, 3, 4, 5 spaces. So here's the space for the first one, and 2, and 3, and 4, and 5. Do the best you can for equal spaces. I don't know if that's good enough there. 0 to 2, 3 to 5, 6 to 8, 9 to 11, and 12 to 14. Okay, so histogram is basically a bar graph of these values to show the different frequencies. Maybe they have us, describe the shape. We'll probably talk about askew if it is, and then symmetric if it is, things like that. From 0 to 2, the frequency is just 1. That occurs halfway between 1 and 2 like that, and there's my bar. 3 to 5 is 3, halfway between 2 and 4. All these are going to be odd numbers now. Oh, 6, never mind. 6 and 16. Wee. And 4. Was there context to this question? Oh, quiz score. 4? 4. All right. Okay. Not quite symmetric. If these were swapped, yep, totally. Looks like this thing has more data bunched on the right side, and then it tails off on this left side here. That is known as left skewed. Skewed left. So I'm going to write that. This is skewed left. More of the data is on the right side, which is good for the students on quiz scores. Only one person got between a 0 and 2. And that's it on number 7. Number 8. The table shows the prices of 8 mountain bikes in a sporting goods store. Hold on. I'm going to start the next page because that's the end of the binder paper. Okay. Okay. Find the mean, median, mode, range, and standard deviation. That's just part A. So we got a lot to do. Okay, I see the information. Guys, first thing I'm going to do is I'm going to start with mean, but I'm going to rewrite these in order to start. And I'm feeling like that's something I used to do at the time when they were asking me to as well. So the smallest number looks to be 95. And then a couple 98s there, right? How many numbers are there in general? 1, 2, 3, 4, 5, 6, 8. So another median will be another even numbered set, which I wish there were less of those so you could practice different things, but oh well. Okay, hundreds. Oh, 100 is an actual value here. So 100, 119, 125, I think I see them all, 130, and 211. Okay, now I can look at my list and not theirs for now, at least. 1, 2, 3, 4, 5, 6, 7, 8. Okay, the mean. I'm going to add them up and divide by 8. I'm going to actually use the calculator right now, if you don't mind. So 95, 98, 98, 100, 119, 125, 130, and 211. Okay, so I'm getting 976, and then I divide it by 8, and I'm getting 122. That is the average price of the mountain bikes in the sporting goods store. There we go. Tongue twister. The median value, just the median, not inner quartiles. We need to average the two middle values here. 100 plus 119 over 2, or 219 over 2, which is 109. 109.5. 109.5. To us, I kind of feel like doing that. $109.50. I don't know. 109.5. Either or. Mode. 98's your mode. It's your only one that shows twice, which is more than all the other ones. So the mode is 98. Once again, I would consider the median probably to be the better center, assuming these aren't. That 211 really pushes up the mean, and the mode is as a very low thing. It doesn't really represent the data in a centered kind of way to me. These are all dollars, really. If I'm going to do median that way, I might as well do the rest that way. Okay, range and standard deviation. Now that we put these in order, the range is actually going to be helpful to do there. 211 minus 95 is going to get us there. And that value is going to be $116. Now, standard deviation would also be in dollars, by the way, and I'll do it to 2 decimal places because that just seems right. So standard deviation, we have the mean, which is good, and we're going to find the differences between these values and the mean. So 95 minus 122, we're going to square that, etc. So let's see here. I need to write some things out probably. 95 minus, I don't want to do that. Minus 122 is negative 27. 98 minus 122 is negative 24. 100 minus 122 is negative 22. 119 minus 122 is negative 3. 125 minus 122 is 3. 130 minus 122 is 8. 211 minus 122 is, I got to think about it, 211 minus 122 is 89. Oh, wow. All right, and use the calculator for that. Divide this all by 8. That 211 really does change. It really is an outlier for the data. I'm not loving the stuff that's going on there for it. This is all part A still, by the way. So let me use the calculator for this part. Square root of, and I'll type it exactly as I wrote it if you love it that way. Negative 24. Even if I know some of these numbers, I actually don't know if I know 27 squared, but 24 squared I know is 576. Negative 3. See, like I know this is 9, and the other one's 9. This is 18. Plus 3 squared. I'm not going to put parentheses around these ones here. 8 squared. I don't know 89 squared. Must be close to 8100, though. Okay. Divide this all by 8, and I've taken square root. And here we're going to... Wow. Exact number. Thank you. I like that. This is one I could explain more on the bikes, the 38, 95, 99, 68, 95, 99, 7 rule if you'd like me to. Add and subtract $36 from the mean, which is 122, and you can say how much within the data. But this is not a good thing to use. This outlier is really causing us to not explain how this data is best represented, at least in a small sample size way. But there's your standard deviation, and this is in dollars as well. Okay, that's part A. Part B, identify the outlier. Okay, well, I told you it. How does the outlier affect the mean, median, and mode? The outlier is 211. It sticks out. It is not, when you look at these numbers here, it's not just because it's 200. No other ones climb up toward 200, much less 150. These numbers are all kind of together as one thing, and then there's the flagship kind of bike model that's there. That's the outlier. So $211 bike is the outlier. How does it affect the mean, median, mode? The question is what it does to them if it wasn't there. So if it wasn't there, what would change? The mode would not change. The median would. The median would become 100 instead of 109.5, and the mean would assuredly be smaller. It would probably be a better representation of the data than the median, or at least nearest it. So the mean and median will go down. The mode will not change. So mean and median, and I don't think they ever asked us to actually compute them. Maybe at a time they did. Decrease, mode stays same. But that mean assuredly changes, and much better. I'm sorry. If the outlier there, did they say, how does the outlier affect the mean, median, mode? So they increased as a result of being there. I was saying if you removed it, what would happen? The mean and median increase because of the outlier being there. The mode still stays the same. Part C, make a box and whisker plot that represents the data. Find and interpret the interquartile range of the data. Identify the shape of the distribution. There's a lot to do on this question. So we have this stuff here. We have the median. Let's get our 5-number summary in full. So we need these other numbers here. This, we include the outlier for it. That'll kind of show us that right skew of our data. So 95 and 211 are our min and max. I'm not going to put the dollar symbols there. 109.5 or 50 cents. And this Q1, Q3, once again, it's the medians of these values. They're, okay, so 98 is Q1, and halfway between these things here, 127.5 is Q3. Sorry for getting kind of scrambled there. 98 and 127.5. Okay. Now I don't know how to push these things best here. That's a lot of data to kind of take care of. I'll probably just go by tens and see what I can fit, because there's just a lot to do there. Starting from 90 and having to go to like 220. So I need a lot of data to fit there. 100, 110, 120, 130, 140, 150, 160, 170, 180, 190, 200, 210. Oh boy. Oh well. 211's right at the end there, so I think we're good there. 100, 150, 200. Okay, let's get rid of those other numbers there. It looks a little messy if I don't. Okay, so 95, halfway between those two. 98, oh, very close still. Not even yet at 100. So that, yes, this skew, man. This skew. 109.5 might as well be at 110. You can probably barely tell, so I'll put it just to the left. Yeah, just inch to the left. 127.5, this is 110, 120, 127.5. 3/4 of the way to the next one. So here's your box. That's one of your whiskers on the left side. This right whisker, guys, 211. Way over here. Whoa. Whoa, 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 whoa. Okay, what do they want? They said identify the shape of the distribution. I can say it's skewed right. That's for sure. Skewed right. Hey-yo. Find and interpret the interquartile range. The interquartile range is the difference between Q1 and Q3, called the interquartile range, IQR. IQR is this range right here, which is $29.50, 29.5. So what they're saying, the ranges themselves, these all represent the different 25% of your data. This little bit right here is where 25% of your data fits. 25% of the cheapest, the cheapest 25% of your bikes are going to range between $95 and $98. That's, I mean, this is a small sample size, but that's the idea. And then the next 25% is here, the next 25%. So the middle 50%, of the bike costs, the middle prices, the middle half of the bike prices vary by $29.50. I'll say 50% here, the middle 50%, just so we're talking in terms of percentages. And that's my interpretation of that thing. Is that all we had to find? Identify the shape. We got that here, skewed right. Okay. Number 9 yet? No. Now we got to do all these things here. And oh, this is the part I'm not going to remember off the top of my head. So maybe I should think about this thing here before actually talking about it. Find the mean, median, mode, range, and standard deviation of the prices when the store offers a 5% discount on all mountain bikes. Now, I want you to think about what values change, and do they all change? Actually, I think they do. If they increased by addition or subtraction, then the range wouldn't change. The standard deviation, to my knowledge, shouldn't change, but the mean, median, and mode, they would be like $5 less or whatever. But you're doing 5% of, I believe you just take 5% of all of your values. So 5% of this, 5% of that, 5% of that. Because you're actually taking 5%, or sorry, 5% off. 5% off of these things. So that would be your new mode, whatever 5% off of this is. And then these things all shrink by those amounts. So I think you're taking 5% of everything. So let me find these, or take these values here, including standard deviation. Let me take these values here and make sure I have them in. That didn't copy anything down. Make sure I have them copied for my. There we go. For my visibility. All right, the new mean. All of these values we're doing. A 5% discount means 95% of. So I have to do $122 times 0.95. The median, I have to do $109.50 times 0.95. The mode, I think, was $98. I got to do 98 times 0.95. The range, 95% of the top, 95% of the bottom, and subtract them. You'll just take 95% of that range. 95% of 116. And then 95% of your standard deviation, which is 36 times 95. That's the one I'm thinking I could probably do in my head, but I'm having trouble right now. All right, here we go. Okay, first one, 115.9. These would be in dollars. $115.90. How about that? It's the average. Again, there's still that outlier involved when we bring up that number, but it's whatever. 104.025. Now that's, you know what? I'm not going to put the dollar values now because I want to have the exact number here. I don't want to round it. So 104.025. I'm just going to write it exactly. I'll let them deal with it as it is because it is, after all, median value, even though it's a price. 98. 93.1. Sorry, I'm typing wrong. 116 times 0.95. 110.2. Then this last one. 34.2. I don't know if I could have got that. Okay. Is that part D? That is part D, yes. Okay. Last question, number 9. The table shows the times of 20 presentations. Display the data in a histogram using 5 intervals beginning with 3 to 5. Now this is out of section 7.3. It is one that I just did, and the way that I did it at the time was I made like a it wasn't exactly a stem and leaf plot, but I showed what intervals we're referring to and how often they occurred before I made it into the actual thing itself. So 3 to 5 is our first interval there. They said 5 intervals. This is 3 numbers, and then 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And then I just tallied them off. Now, normally I'd pause this thing. I can go pretty fast here if you let me, though. So 9, 10, 10, 9, 6. I won't cross them out, though. 6, 7, 11, 17, 10, 14, 10, 8, 11, 4, 8. Hopefully I don't mess this up. 12, 10, 5, 12, and 10. Okay. All right, so there's my frequency stuff there, right? So now we're going to make a histogram off this stuff as well. Let's see if I can just fit it here on the side. We are going up to 10, so 2, 4, 6, 8, 10 should be enough. Okay. And then those 5 intervals. 0 to, not 0 to 3. Shoot. What was this for? Times 20 presentations. All right, here we go. 2, 4, 10, 3, and 1. Okay. Display that. Which measures of center and variation best represent the data? Explain. Now, this is based off whether this is symmetric or skewed. There's a little bit of right skew, but not enough to take this away from just being symmetric overall, right? This is a symmetric data set here. Because it's symmetric, relatively so, I'd want to use mean and standard deviation as opposed to median and 5-number summary. So the data appears symmetric. So I would use the mean as my center, measure of center, and standard deviation as my measure of variation. No real outliers to speak of. Excuse me. The presentations are supposed to be 10 minutes long. How would you interpret these results? So, that's a good question. I was trying to say how many, because every time they tend to ask this question, they'd say, if it said most of them are supposed to be about 6 minutes long, I'd say, well, most of them are longer. You know? If they're supposed to be 10, most of them try and get around 10. Even if I add these other ones, 2 plus 4 plus 3 plus 1, that adds to 10 in and of itself. 10 of them are between 9 and 11 minutes. 10 other ones are not, and there aren't very many, and they don't spread out. Most of them are about the right length. So this part B is here, and then part C, I'd say they don't fall off very far. This is good. So most of the presentation, that I want to see. Most of the presentations are about the right length of 10 minutes. I don't even know. They said 9 to 11. Oh, we actually have the numbers here. I forgot. So there are 1, 2, 3, 4, 5, 6 of them that are actually 10 minutes in length. The 9 and 11 just occur 3 times, whereas the other, or something like that. So, or 4 times. So that's good. It's good stuff right there. And the histogram kind of spells that out pretty well. All right, that was the last question, guys. So that ought to do it for this one. This is Mr. Robinson. Thank you so much for watching. I didn't anticipate this one to be over an hour. I apologize. I know I spoke more than I should have at times, but those standard deviation problems ask a whole lot out of you, and I really tried to go as fast as possible for myself, for you guys as well, and I hope this was helpful. Thank you so much, guys. Take care. I will see you in the next one, section 7.4.